In this STR8CHEM session, we're going to learn about collision theory. The theory consists of two main ideas. Number one is the particles, which are atoms, molecules, or ions. They must collide with one another in order to react. So imagine you have particles of reactants right there. In order for you to have products to be formed, these particles, they need to be colliding with one another. And the collision between the collision between these particles over here to form your product, it needs to be effective collision. Okay? So it's important for you to remember the particles will be colliding with one another to have a reaction, and the collision needs to be effective collision. Now, effective collision will have two requirements. So if you want to have effective collision to happen, the molecules, they need to fulfill two requirements. Number one, the molecules, they must collide at correct orientation. Meaning to say the particles, they need to get into the correct position. If you must say like that, then when they collide at the correct orientation, so you might gonna have the reaction to occur. But to get correct orientation here is not enough, because the molecules which are trying to react with one another to make products, they also need to have kinetic energy which is equal to or greater than the activation energy. So those are the two requirements for effective collision. I repeat, number one, the molecules, they have to collide at correct orientation. And second, they have to possess kinetic energy, the energy of the movement of the molecules, that is equal at least or greater than the activation energy EA. So what does it mean by correct orientation? Let's say we have this reaction over here when you have NO gas plus O3 gas to make NO2 gas and O2 gas. So if you want to get NO gas and O3 gas to react and to make your product right there, the molecules of NO and O3, they have to collide at the correct orientation. Let's say the red ball over here represent the oxygen atoms, okay? So I'm just gonna, this will be represented by the red ball, okay? So you have it right here, and the blue ball right there is representing your nitrogen. And we have another oxygen right there. So if you want to get this NO to get one of the oxygen from O3 to make NO2 and O2, the N from your NO here needs to collide with one of the oxygen, like what you have in there. So as you can see, I'm going to write it in there. So this is the N, that is the O, and O, and O, and O. So when you look at the area right there, so they are colliding at the correct orientation. So they are colliding at the correct orientation because you want to get that area to be colliding with one another. So this is the correct orientation. Then you will be able to make NO2. So now you get the oxygen right there, and the nitrogen is still there, and you get also the O right there. Okay, so this is roughly how we represent or how we visualize correct orientation to happen. What does it mean by wrong orientation? So we're going to take the same reaction, just now what we have. So again, the blue ball will be representing your nitrogen, and the red ball will be representing your, sorry, I'm going to use red ball representing your oxygen. So I'm just going to put nitrogen here, oxygen, 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 and oxygen. So if you have the oxygen end of your NO right there, this is the one that will be colliding with the O3. You will not going to get any products. You will not going to have any reaction, because this is what we call as the ineffective collision. Collision that is not effective. If you look carefully, the reaction is trying to occur by having the oxygen atom from an O particle to hit or to collide with the oxygen atom from the O3 particle. So the collision is happening there. This is what we known as, it is known as the ineffective collision. Therefore, you do not have any products if that's going to happen. But, okay, so there's a huge buts over here. It is not enough for the molecules to collide with correct orientation. It's not enough. It's good for them to get into the correct orientation, but if you want to get the reaction to move further forward after they have got the correct orientation, the molecules also need to have kinetic energy that is equal to or greater than the activation energy. So what is activation energy? Activation energy, the symbol of it is EA. EA is defined as the minimum amount of energy. Okay, you need to write the minimum amount of energy that is needed by the molecules that are reacting with one another to start the reaction. Okay, so EA is defined as the minimum amount of energy needed by the reactants or molecules reacting together to start the reaction. So this is the definition for activation energy. So the molecules, then it gets into correct orientation, and together with that, they need to have the kinetic energy that will be equals or greater than the EA of the reaction.